So it says, find the reference angle. Now, to remind you, the reference angle is the angle between the x-axis and the terminal side. So in this instance, just drawing it in, this right here is the reference angle. Or this right here is the reference angle. So to find that, essentially, we're going to have to do a little bit of subtraction. We know that this is negative pi. So if I get rid of that negative pi as part of the, like if I subtract that part out, then you're going to be left with that. So negative 225 pi over 18 minus negative pi. Well, negative is a positive. I have to find the common denominator. So that's going to be negative 7 pi over 18. Now your reference angle is always positive, and so in this instance, we just make it positive because it has nothing to do with negative rotation. But I do know then that what's left here is 7 pi over 18. Now, for this next one, because it rotated once, right, to find that little bit left, it might be nice to know what the full second rotation is. So if I know the entire second rotation, and then I could subtract that, and then if I subtract that, it should give me the difference in my angle. So if I know it's 360 for one, well, if I go around again, that's 720. So then if I subtract out the 720, that gives me 80 degrees. So what's left here is 80 degrees. And you can kind of think about it, because how do I get to 720? I have to add the 80 degrees to the 640. For 3, let's draw it. So it's not quite negative 270. So it's going to be in here. So there's my negative 250. Again, here's 180 degrees. So if I subtract out the 180 degrees, you're going to be left with 70, negative 70 degrees. But that's what this is in the negative rotation, but it needs to be positive rotation, so I can just leave it at 70. This is given the reference angle. What's the angle in standard position? Okay, so I need to find the angle in standard position for all 4 quadrants. So what that means is, if I were to say that, rotating, here's 50 degrees, here's 50 degrees, here's 50 degrees, and then here's 50 degrees, right? So those are the reference angles in all 4 quadrants. What it's asking is, what is that angle? Right? Because I'm already given one. I have the 50 degrees. That's in quadrant 1. But what about in quadrant 2? So even though I know my reference angle is 50 degrees, it's asking, if I rotate to that reference angle, what would that be? So that's going to be 180 degrees minus what my reference angle is. So that's going to be 130 degrees. This one is going to be 180 degrees plus what my reference angle is. So in quadrant 3, that's going to be 180 plus 50, so that's 230 degrees. And then quadrant 4, I could do the same thing, but if I imagine 360 minus my reference angle, that's going to stop here, which is where I want my rotation to be. So that's going to be 310 degrees. So next one, it says find a positive and negative coterminal angle. And so 11 pi thirds. So that means I need to add 2 pi or subtract 2 pi. And I might have to keep adding or subtracting 2 pi to make sure that, I get something that's either positive or negative. So, or, I can just subtract it twice. I'm going to do that. So if I subtract it, that's really 6 pi thirds. So 11 pi over 3 minus 6 pi thirds is 5 pi thirds. There's my positive. Now if I subtract the 6 pi thirds again, that's going to get me negative pi thirds. So those are my two coterminal angles. So for this one, I can add 360 to it. And so 435 and 360. So that's 5, that's 7. So that's going to be negative 75. So there's a negative coterminal angle. If I add 360 to that again, so that's 5, 8, 2. So then I also get positive 285. I think this is supposed to be 6. But it's a duplicate, so we'll skip it. Convert each radian to degrees into degrees to radians. So remember, you either multiply by 180 degrees over pi or pi over 180, and then you're going to simplify it. So pi over 180, then you're going to go through and simplify it. Or this one would be 180 degrees over pi. You go through and you simplify it. Right? So the 3 and the 60, negative 4 times 60, so that's negative 240 degrees. Now you want to do the best you can to simplify it as a whole number, right? So, I can divide that by 5, divide that by 5. What do you get? Does it divide further? Things like that. So given the formula, S equals A over T, where S represents the instantaneous speed, D represents the distance, the units of meters, and T represents time. Select an appropriate measurement unit for spontaneous speed. So what is the measurement? So S equals meters over seconds. Right, I'm just putting the units where they're supposed to go. So A over, that's D. It's cut off, though. That's the issue. So that's S equals D over T. And so the D is M, so M over S. So that's going to be B. An aircraft flies at a speed of 480 miles per hour. It takes the aircraft T hours to reach its destination. Enter an equation that can be used to find the number of hours it would take the aircraft to reach a destination that is 1,200 miles away. So aircraft flies at 480 miles per hour. So we need to know that the equation distance equals rate times time. So if it says an aircraft flies at a speed of 480 miles per hour, it takes the aircraft T hours to reach that destination. In an equation that can be used to find the number of hours it will take the aircraft to reach the destination. So that's going to be 1,200 equals 480 T. So there's going to be some variance in the way that it's expressed. So, the 1,200 equals 480 T should work, or 1,200 over 480 equals T should work. Or actually, simplify that further, equals T. So T equals something.